Here we're going to look at how we can work out the pH after adding strong acids and strong bases. So I've been given the concentration and volume of my strong acid, which is my hydrochloric acid, and the concentration and volume of my strong base, sodium hydroxide. First thing we need to do on a question where I'm mixing strong acids and strong bases is work out the moles of hydrogen ions. Now, being a strong acid and a monoprotic acid, the moles of HCl will equal the moles of hydrogen ions. So I simply use the concentration and the volume of HCl given, which is 0.200 times 24.0 times 10 to the minus 3. And that gives me 4.80 times 10 to the minus 3 moles. And that's the first marking point usually. The next thing we need to do then is work out the moles of my hydroxide ions, which again we can work out from the concentration and volume of the sodium hydroxide, because it's a strong monoprotic base. The concentration of hydroxide ions will equal the concentration of the sodium hydroxide. So it's 0.200 times 20 times 10 to the minus 3, and that gives me 4 times 10 to the minus 3 moles. That's my second marking point. What we then need to do is look at and see which one is in excess. 1 mole of hydrogen ions will react with 1 mole of hydroxide ions. So we can see that we've got an excess of hydrogen ions. So you then work out the moles of H plus in excess, which is going to equal this value minus this value. So you'll get 4.8 times 10 to the minus 3 minus 4 times 10 to the minus 3. And that gives me 8 times 10 to the minus 4 moles. And that's my next marking point. I cannot now simply do minus log to the base 10 of this, which is a very common thing that I see when teaching students. The step now is the one that most people forget, so I'm making a big point now. Don't forget to do this. You then have to convert this into the concentration of hydrogen ions. So your hydrogen ion concentration then is equal to 8 times 10 to the minus 4 divided by the total volume, which is this volume plus this volume here. And that's 44, obviously, times 10 to the minus 3. And that would give you a hydrogen ion concentration of 0.0182 moles per decimetre. And that's your next marking point. And then you need to work out the pH. So pH then is equal to minus log to the base 10 of your hydrogen ion concentration, 0.0182, and that gives you a pH of 1.74 to 2 dp. So these calculations, they're not too bad. You've just got to remember the steps. Moles of hydrogen ions, moles of hydroxide ions, work out which one is in excess, then convert it to a concentration. Once you've got the concentration of hydrogen ions, you can then work out the pH.